Continuing on, we're actually going to look what happens when we try to multiply a binomial by a trinomial. And using the three methods as quick as possible, I promise, using the three methods that we've already learned how to multiply a binomial by a trinomial, we were trying to build a better idea of which one you want to get good at to see how you can use it on other skills as they get more complicated or really just longer. All right, so what we need to recognize is the first thing that we did is we basically said we take every term of the first group and we're going to multiply the second group each time by the first term. In other words, the first term in my first group is x, so I'm going to multiply the second group all by x using the distributive property. Then I'm going to realize that I have another term of a positive 5. So I'm going to take that same second group and I'm going to multiply it by positive 5. And at the end, I'm going to combine all my like terms. So that becomes x cubed, because this is x times x squared. I add the exponents, 2 plus 1 is 3. This becomes negative 3x squared, same reasoning, and minus 2x. Over on the other side, where I'm solving for the second equation, or sorry, the trinomial being distributed out with the 5, I get a 5 times x squared, which is 5x squared. I get a 5 times a negative 3, which is negative 15, and keep that x. And then I have a positive 5 and times a negative 2, which gets me negative 10. Then I'm going to look through for like terms. I have an x squared and I have an x squared, so I'm going to want to combine those. I have an x and an x, I'm going to want to combine those. And the other two, the x cubed and the constant of negative 10, have no other like terms, so I just keep those. So I'm going to have x cubed, let's see, negative 3 and positive 5. That is going to be a positive 2x squared. Then I have a negative 2 and a, I should have made that green because that's what I underlined it in. My apologies. So this was a positive 2x squared. So now, looking at the x terms, I have minus 2x minus 15x. That gives me negative 17 x's. And then a reminder that 10 was on its own. So here is my answer to multiplying a binomial and a trinomial. Let's check it with the table as quickly as possible. X times x squared is x cubed. X times negative 3x would be negative 3x squared. And x times negative 2 is negative 2x. 5 times x squared is just 5x squared. 5 times negative 3 is negative 15x. And 5 times negative 2 is negative 10. I know that my x cubed and my minus 10 are going to be alone. I can look at the table and know that negative 10 is the only one without a variable, and the x to the third is the only one with a power of 3. So those are going to stand alone. I can then say, hey, here's an x squared and here's an x squared. So if I bring those together, I'm going to get a positive 2x squared, positive 2x squared. Then I can look a little bit further and say, here's an x, there's an x, everywhere an x, we get negative 17x when I combine those two. And that happens to be the exact same answer, different method that we got before. Now let's look at FOIL. This, I believe, is one reason why people get confused by FOIL. FOIL is for binomials. We can still use the concept, but it doesn't transfer exactly. Everything we've done so far has been exactly what we did before. It's just adding that extra term to make a trinomial and a binomial. FOIL, you can't really do that because FOIL says start with your first, multiply your first. Keep with your first, go to your outer. The problem is I've now skipped this -3. I'm not taking it into account. So FOIL, as it's worded, doesn't work but for multiplying a binomial and a trinomial. But it's more of a shortcut idea that all we're really doing when we're using FOIL is we're taking our first term and multiplying it by every term in the second. So it's kind of like thinking of it like the distributive property, only I'm not writing it out. I'm just remembering I take this first x, I'm going to multiply it. Well, the first one gets me 3x squared. The second one here, where I have my second line, takes my x times my -3x, which is this is cubed. This is -3x squared. I need to make that look a lot better because it does not look right. That's supposed to be cubed. My apologies. And I said cubed as I was trying to write squared. And there, my corrections are messed up. That's where I put my 3 on that one. So my first multiplication is x times x squared, and that gets me x cubed. My second multiplication is x times -3x, which gives me -3x squared. And x times -2 gives me -2x. After that, I'm going to take my second term and then multiply it by each term in the other group. So here I get 5 times x squared. That gives me a positive 5x squared. And I'm already going to go ahead and line that up with the other x squared because I know I'm going to have to combine them. 5 times -3 gets me -15, and I'm putting it here because it also keeps 1x. And then I have 5 times -2, which is -10. Now, I can look at this and go, well, there's nothing here, so I just bring it down. There's nothing to combine it with. Here, I have a -3 and a positive 5. That's going to get me a positive 2x squared. And as a matter of fact, I tried to make that orange and apparently missed. So let me go ahead and do this. I'm doing that because the larger number wins here, so that makes it positive, and the difference is 2, so that becomes my new coefficient is the 2. X squared comes from they both already had x squared terms, so I keep the term. All right, here I have a negative and a negative, so that makes its negative answer. 15 and 2 makes 17, and I keep my x. And here I had my -2 to begin with, nothing to add or subtract from it, so it stays exactly as it is. And now I can see that again, I got the exact same answer, just a different way. So FOIL changes a little bit. It's not just first, outer, inner, last, but we can use the same idea. And what that idea actually was is I'm going to take my first term and multiply it in order to each term in the other group. Then I'm going to take my next term in my first group and multiply it by each individual term in the other group. And I'm going to keep doing that. You'll actually find this way helps us multiply trinomial by trinomial, or a fourth, oh my goodness, if there's 4 terms or 5 terms or 17 terms, no matter how many terms there are in each group, we can multiply them using the idea of FOIL, just not exactly what we started saying FOIL was.